Okay, 6b, they're asking us each of the following values of cosine theta. So they're talking about all of our questions deal with cosine theta. So we'll put this as our stipulation. Cosine theta is equal to whatever the question is they're giving us. And they're saying that the other stipulation is theta is less than 2 pi, but greater than pi itself. Okay, so these are the questions they're talking about. And 6b gives us the root of 3 over 2. Okay, and they want everything in radian values. Okay, so convert to radians. Now there's a couple ways we can go through this. Okay, one of the ways is to actually refer it to our special triangles. Okay, so what we're going to do is we're going to go to a unit circle. Okay, and this is first of all only talking about between pi and 2 pi. So we're going to go to our unit circle grid. So what we'll do is we'll copy it to the page. Here's our unit circle. You know what I'll do? We'll do it the other way around. Okay, so when we go to take a look at this, they've put it like this. Okay, this is the plane we're on, and what's very important first is to always figure out, because they're talking about our actual radian movements, we know this is going to be 0. This gives us a half pi, 3 over 2, so 1.5 pi, and our other option is 2 pi. So in other words, they're discussing only from here to here, the values of root 3 over 2. So when we go to take a look at this, root 3 over 2, we're looking at that when that is our, when cos theta is equal to that. So one of the first things we got to remember is when cos theta is going to be positive and negative. Okay, and if you remember from these quadrants, we have quadrant 1 or a cast system, right? So our answers here, this is when cos will be positive in this quadrant specifically here. Okay, now let's take a look at your. So like we were saying with our cast system, when we take a look, we do have a value of when x is 3 over 2, or theta, and theta is the angle we're talking about here. Okay, so we do have an option when it's negative 3 over 2. Okay, but the problem is we're not looking for a negative, we're looking for a positive. So our other option is when we're positive 3 over 2. So let's kind of refer this back to our radian circle with everything involved. When we're positive 3 over 2, in terms of radians, we're looking at 11 pi over 6. Okay, that's exactly what they're talking about in terms of degrees. This is our x value. Always refer to it as our x value when we're going through it. Because if you notice, this is giving us points, an x and a y value. When we're talking about theta itself, we're just going to be looking at these. Okay, because technically the other option here is, oh no, okay, that works out fine. We have 11 pi over 6 as our answer when we go back to look at it. Okay. Now, if we have to solve this algebraically, we're going to set this up as an equation. We have cos theta is equal to the root 3 over 2. Okay, so when we're trying to actually find out what theta is equal to, we've got to bring cos to the other side. So we're left with cos theta inverse root 3 over 2. Okay, now that was a root 3 over 2. Now when we go to type this in the calculator, we're going to run into, okay, so a couple of problems when we go in the calculator. Let's just go through this slowly. So because this is an older calculator on the computer here, this one will look a little funny. But first, this is how we enter it. We have our bracket. I put the square root of 3, which they've given me, divided by 2. So I've divided it by 2, okay, and that is going to equal a large number. Then I got to put that to the inverse of cos. So my inverse cos, I click it to that number, our answer is 30. So in other words, they're talking about 30 degrees. So this is when theta is equal to our 30 degrees, okay? So we've not put that in the calculator. Now one of the formulas, when we're going from degrees to radians, we're actually going to be multiplying that by 1 over 180 degrees. Okay, does this make sense so far? Yeah. Okay. Then when I multiply that, I'm left with 30 over 180. And if we want to bring that down, it's essentially, sorry, it's also pi. Don't forget the pi involved. So 30 pi over 180. When I bring that down, that's actually going to be 1 over 6. So it's like having 1 times pi over 6. Oh, that's the mistake we made, sorry. Which is pi over 6. Okay.
Yep.
Now, the only problem with this is we're not between what we said we needed to be between. We said we needed to be between pi and 2 pi, correct?
Yeah.
This is not between pi and 2 pi. This is too small. So what we're going to try to do is refer this to our circle. We'll make a small, XY axis here, okay? So we're talking about 30 degrees, which is what we found earlier. Let's fix this here. That should have been, sorry, 1 pi. 1 pi times over 80. Again, we know that that is when we're going through quadrant 3 and 2 pi, right? And into quadrant 4. So we're looking for 30 degrees in that. The other problem is we're talking about cosine. According to our CAS system, when we have a positive answer there, is we're in quadrant 4. CAST, that would be when tangent's positive. So our 30 degrees, that would be either here 30 degrees, or we have here as 30 degrees. So we discovered the acute angle, which is pi and the 6th. Okay. Now, there's a couple ways to think about this. We can think about this as this is not going to be involved because we're not going to be positive there. So we're looking for the angle that comes all the way around here. Now, we know 2 pi is also equal to 360 degrees, correct? If we're going all the way around here, minus the 30 degrees we were talking about before, how many degrees movement is that really? We're talking about 360 degrees. Subtract our acute angle, which is 30 degrees. We're talking about 330 degrees. Okay? So this is one way to look at it, 330 degrees. So instead of having 30 degrees, we can be putting in our 330 degrees, okay, as a side calculation. So these were our side calculations. Let's do a side calculation of 330 degrees times pi over 180. And then when we go to reduce them, I think we can reduce each of them by 30. In fact, we can divide both those numbers by 30. Does this make sense so far?
Yeah.
330 pi over 180. Okay. When we divide both of them by 30, when I divide 330 by 30, I get 11 pi. And when I divide 180 by 30, so I'll just do it quickly here. 330 divide 30 gave us 11. 180 divided by 30 gave us 6. So we were left with 11 pi over 6.
She doesn't want us to
do it in degrees.
She's
And then the other option,
leaves it in
radians. The other options, if we have radians, exact same idea. We have our 2 pi, right? So we have our 2 pi, which is our 360 degrees. And we know our acute angle is pi over 6. So we're subtracting pi over 6. Okay? Yeah. So now what we have to do is our fraction rules. We have to remember them. Technically, this is 2 pi over 1. So I need to have a common denominator. I'm going to have to multiply this fraction by 6. So that's going to give me 12 pi over 6. Subtract pi over 6. That's not a subtraction. Pi over 6. 12 pi subtract 1 pi will give us 11 pi over 6. Okay, question 6c. Same idea. This time we have negative root 2 over 2. Okay. Again, we know it's going to be cosine theta is equal to negative root 2 over 2. And we know we need to be between, theta needs to be between pi and 2 pi. Okay. So first thing we're going to do is convert this to degrees so we can work with our Cartesian plane. So it makes a little more sense to us. Theta is going to be equal to cos to the inverse of negative root 2 over 2. Okay, let's go plug that into our calculator. We're going to get number 2. So number 2 square root, and make it negative, divided by 2 equals, and then to the inverse, we're going to get 135 degrees. Now the other option of that, it is 135 degrees. They've given us the obtuse angle. It's also good if we just keep an idea of what the acute angle of that would be. Okay. So in other words, as a side calculation, we had 180 subtract 135. It's going to give us 45. Yeah, 45 degrees. So important that we know that we have a 45 degree angle too. We're just going to relate this back. Okay. So when we look at our plane, again, remember we're between pi and 2 pi, so we know we're only in the third and fourth quadrant. And we know we had 45 degrees, okay, which means we're going across this line here and or this line here. Oops, sorry, that's the wrong one. This line here. This is 45 degrees, and this is 45 degrees. But we're working with cosine being negative. Well, in this quadrant, root 2 divided by 2 is a positive x value, while in this quadrant it has a negative x value. So really quickly, we can already kind of tell where our answer is going to be. But let's actually equate this and solve this question.
Yeah, you did. I figured out where I went wrong. I didn't find that related.
Yeah. So because we put in, when we were calculating negative root 2 over 2, because of cast, A-S-T, anytime we're putting in a negative for cos, that means they're going to end up with an obtuse angle, which is why we got 135 degrees, right? Yeah. But we always need to find the related acute angle, which is our 45, which are going to give us 4 45s around the board.
When you're finding your related acute, you always...
Okay, so 7a, we need to find the radian angles, and for 7a, they've given us the point of the arm passing through negative 7 and 8. So what we do know, let's make some room here. What we do know is we're going to have a value going through 1, 2, 3. We're going to have some point at negative 7, let's say, and positive 8. We know we have something like this. They want the measure of the terminal angle. So assuming they're looking for the full length, we're going to find the acute angle. What's good about this is we can actually create a triangle out of this, right? So I know that the height of this is going to be 8, right? And our base is going to be 7. So I can now find the distance, and using our SOHCAHTOA, I can find our angles, okay? I'm going to give that. Okay, so when we go to take a look at this, we know that we have, this is back 7, so negative 7. So let's quickly take a look when we go to put this into our cast system. We see C-A-S-T. We were looking for the angle, and it's, when we're going through our SOHCAHTOA, we have opposite and adjacent. So we know we're dealing with tangent when we go through this. So we're talking about tangent theta is equal to opposite, which is 8, over 7. Now, I think it may be negative 7 because we're going back, okay? So when we go to do this, we're looking for the angle of theta. Theta will equal the inverse of tangent, 8 over negative 7, okay? And because they want this in radians, we're going to try solving this in radians, okay? So move the radians, clear this. We have 8 divided by negative 7, okay? And then when I find the inverse of tangent, I ended up with 0.85. Yeah, you got 0.85? Okay, sorry. We still have the right answer. We got, let's quickly type it in again, 8 divided by 7 when it's negative, tangent negative 0.851, we'll say, okay? So we got negative 0.851, which makes sense. Now, the thing is, this is the acute angle, what we found. We're trying to find this angle, which is the obtuse angle. And in terms of radians, we know going from 0 to here is pi.
Yeah.
Okay? Pi actually has a value, which I completely forgot to negate it earlier. Pi's value,
314.
yeah, is 314, right? Or what we can do in our calculator, because it's exact, is we can subtract from pi now. We know that pi, subtracting our acute angle, which is 0.851, okay? Pi subtract 0.851, which will give us this angle here. We type it in our calculator. There we get pi subtract 0.851 equals 2.290. 2.290, which is exactly what they were looking for. Forgotten to subtract it from the full range to get, because we're looking for this angle, not just the acute angle. Okay, so in the question they've told us that our hour hand is pointing at the 3, the minute hand is pointing at the 12. Okay, we also know the second hand is 25 seconds past, right? Is that 25 second past, which means it's pointing at the 5 on a clock. So we roughly made a clock in line with the Cartesian plane. And it also says the tip of the hour hand is just in line of the tip of the second hand. The length of this hand is 9 centimeters, the second hand. And we also know that the acute angle it creates is 60 degrees, right? Because we know we're going up by thirds here to get to this. So we know we have a 60-degree angle. And in terms of the other part of the triangle, okay? Why do we go to 5?
Yeah.
Because on a clock, 1 is at 5 seconds, 2 is at 10 seconds, 3 is 15, 4 is 20, and 5 is 25. And the question says it's 3 p.m. and 25 seconds. So we know we're pointing directly at the 5.
Yeah.
Okay? Okay, so we know it's 25 seconds. We also know the distance is 9 centimeters. We've created a right angle triangle. So we can, well, actually, we're not going to exactly use special triangles because the hypotenuse is 9, which is an odd number. But we can set this up just the same way we did the other question and find the length and width according to our 60 degrees. If we use our, for instance, if we use sine. Sine is talking about sine theta. Our theta in this instance is 60 degrees. We know that. Is equal to opposite. So we'll be solving for that side, which will be our x, over the hypotenuse, which will give us 9. Yeah. So then we solve for x, and then we're going to solve for the other one using cosine. So we use cos 60 is equal to, we'll call it y. Actually, those are backwards. This should be y, and the other should be x, just in terms of the Cartesian plane. This is y, this is x over 9. We solve for those two values, and then we go right into what we did for question 7 in terms of finding what the distance of the hour. Or are they only asking for the distance of the hour hand? Yeah, so they're just looking for the distance of the hour hand. We've set this up. We can use this to solve for it in terms of our radian.